Welcome back to our series on Windows Kernel Exploitation. In part 1, we have covered the basics of kernel driver and set up our development environment. Today, we are diving deeper by writing simple Hello World kernel driver. If you are new here, make sure to check our part 1 for foundational knowledge. Let's get started. Alright, you can see this is in the freeze mode, and we have already put breakpoint on the debugger on the kernel. So it stopped right now, it's not doing anything. But if you want to see the logs, you can just press G key and hit enter. You can see debug is running, so we can go and see all the handlers and all the system calls over from there. So first of all, what we need to do, we need to start the Visual Studio Code and then need to create a new project. So here you need to find kernel mode driver. Okay, so if you are creating this kernel mode driver, so kernel mode driver, there are two things. First come up with few libraries and templates, second one comes empty. So we are going to experiment on the second one. Just click on it and press next. You can give project name here. Project name could be hello world. Yep, this looks cool. Good. Click on create. Yep, we are all set. Right click on hello world drivers. Click on add. We need to create one C++ file. We'll name it drivers. Press OK. And it should reflect inside the source files. Yep. Now in here, first we have to define the header. Prototype include. So this header file ntddk.h is a necessary for writing kernel mode driver, as it contains definitions for various kernel mode structure functions and macros such as debug print, Unicode strings, driver objects, and pointer to the drivers. All of these are present inside the ntddk, and it should be defined every time when you are creating a kernel driver. So after that, we have to tell our compiler that linker should be initialized as C driver entry. Yeah. So this line tells C++ compiler to treat function driver entry using C linkage, not C++ linkage. This is necessary because Windows explicitly expects the driver entry function to have C style linkage. Extern C disable C++ name mangling so that the linker can resolve the driver entry symbol correctly when loading the driver. Driver initialize, a macro is used to declare that this function is the driver entry point. Windows kernel expects every driver to implement this function, which system will call when the driver is loaded. Next thing we're gonna do, anti-status, sorry, anti-status driver entry pointer to the driver object or driver object pointer to Unicode string registry path start. Okay, this is the driver entry point. Now, when kernel mode driver is loaded into memory, the Windows kernel will invoke this function. It is similar to main in user mode application, as it is the first piece of code that driver code that executes. So driver object pointer to the driver object structure. This structure represents the driver being loaded and contain pointers to various driver callback functions such as unloading, handling input output operations, etc. Registry path. It's a path to a Unicode string structure that contains the path or to the driver registry key in the system registry. This can store driver specific configuration data. Here it's not used, so we discard it with unreferenced parameter. So we're gonna define this unreferenced parameter afterwards. So here we'll define unref sorry unreferenced parameter. Reference reference parameter. We have registry path. Yeah, it's unreferenced, so we can exclude this. So yeah, this as I told you, like this macro is used explicitly mark parameter as unused when which prevents the compiler from generating warning about unused parameter. In this case we don't need registry path, so just ignore it. Why should we take it as a parameter if we are not using it? Yeah, it doesn't make any sense, right? Then we will use driver object pointing to driver unload. Okay, lambda anonymous function p pointers to driver object dbg print goodbye. Can write and sorry, I forgot to give new line to make this. Okay, so I think this is pretty much understandable. Like this line assigns a function to the driver unload field of the driver object structure. Driver unload a pointer to the function that will be called when the driver is unloaded from system. Every driver must define a driver unload routine to clean up resources. Yep, and after that we have square bracket p driver object. This is an anonymous function, a lambda, that takes p driver object parameter and prints a debug message when called. Then we have dbg print goodbye slash n. This is kernel mode equivalent of printf. It prints message to kernel debugger if attached. The message here is goodbye, and then which will be printed when the driver is unloaded. Okay, so else we need to print like, okay, driver is loaded, we'll say like, okay, we'll print as hello world. Okay, so yeah, there you go. And after that will return return us status success. Okay, you can see the error. Why the error is, yeah. So this return status success. This line returns the status of the driver load operation. Status success is constant defined in the Windows kernel that indicates the operation completed successfully. If the driver entry function returns anything other than status success, the driver load will fail and it will not be initialized by the system. That's it. So I can see here there we are missing the semicolon. Initialize. Sorry about this spelling, silly mistakes. Okay, you can press Control Save. Now you can go and release this, and you'll say like x86 architecture or ARM, whatever you want. You can just start the debugger. You'll see build started. Yep. Now we have hello world drivers in this directory. Okay, error list. There is no error list. Warnings, no warnings. Okay. uh, so now we are gonna open OSR loader to load our driver and see whether everything is working fine or not. We'll browse this and we'll go and check hello world application, and it was inside C drive, users, wide sources, repos, hello world drivers. That was it. Release hello world sys. Okay, first you need to do this service start as automatic. There are other ways to start these drivers as well. We have so many commands from comes inside Windows kernel driver kit. After that you can also use, is alternative to OSR driver loader, which is kernel loader, but that one is paid. There is commands like pnp where you can put root sys file, and you can attach the inf file which is your certificate. So yeah, that's it. But OSR loader is pretty quick. For that you don't have to hassle and create a separate service of run the separate service command from command prompt, those kind of stuff. Yeah, you can do it easily from here. Yeah, it's just click and boom. So this is why I am using this for the sake of saving time. Yeah, and yeah, but mostly it's all a manual via command only. uh, First you selected this driver. Now register services. Click on OK. Now you need to start the service. Successfully started. So if service is successfully started, then we should be seeing the hello world in the kernel. uh, yeah, remote debugger. So yes, this is working fine. If we exit from here, we stop the service. Okay, and if we unregister the service, it should be unloaded. Goodbye. So everything is working fine. That's it. So that's it for today episode. We covered the basics of writing a kernel mode driver, including how to print messages to the debugger and handle driver unload. In the next part, of our series will deliver more into advanced topics like IO request handling and interacting with the hardware. If you found anything helpful, don't forget to like, subscribe, and hit the notification bell to stay updated with our latest content. And if you have any questions or comments, you can do it below, and I'll try to answer them all. I'll see you in the next video. Peace.